Here's the last related rates example. This is talking about a snow cone. So we have a cone here. It's full of shave ice or whatever, and it's dripping out of the bottom at a rate of 2 milliliters per minute. That means the rate at which the volume is changing for this snow cone is 2 milliliters per minute, and we know that the snow cone is losing volume, so this needs to be a negative 2 milliliters per minute. It's very important to pick up on those little things. The diameter of the cone is approximately twice the altitude. That means from geometry, like this cone right here, can be thought of as a right triangle. From the center of the cone down and from the center of the cone over, we have a right triangle here, where the diameter, which is twice the radius, is twice the altitude, or the height. So that means that the radius is approximately the same as the height. So we may need that later. Let's keep that in mind. I'll move that up here in case we need it. Okay, the cone is 4 inches tall at the beginning, so this cone's 4 inches tall from here to here. At what rate is the height of the cone decreasing? So I'm looking for dH dt. At what rate tells me that's a dH or d something dt is the height, so that tells me dH dt. So find dH dt when there's 3 inches of snow cone left, so when h equals 3. So the first thing I need to do for any related rates problem is to find an equation that relates volume to radius and cones. So the volume of a cone is probably a good place to start, which is 1/3 pi r squared h. Now you see we have two unknowns here, and so the best thing to do when you're doing a related rates problem is to get this down to one unknown first. And I can see that over here r is the same as h. That means on this problem, since r is the same as h, sometimes they're not always the same. Sometimes it's like r equals 1/2 h or vice versa. But anyway, since r is the same as h, I can get rid of this h with an r, or get rid of this r with an h. So since I want to find h's, I want to keep h's in the problem. That's important also. Since you want to find h's, you want to keep h's, which means I need to get rid of the r. So that means I'm going to say volume is 1/3 pi, instead of writing in r squared, I'm going to write in h squared h. Or in other words, 1/3 pi h cubed. So this is exactly the same as my original equation, only I only have one variable now to differentiate on each side. So that's a good thing. Alright, so I'm going to keep going. I'm going to differentiate each side. So the derivative of v with respect to t is dv dt. The derivative of this whole side, remember pi is not a variable, so bring the 3 down. 3 times 1/3 h, 3 times 1/3 pi is just pi. Rewrite the h, take 1 off the power, times the derivative of the peanut, or the derivative of the base, which is dH dt, because I'm differentiating with respect to t, not h. So now I'm looking for dH dt, find dH dt, when the height is 3, and the dV dt is -2, so I can stick a -2 in here, pi, h is 3, so h squared is a 9, dH dt, and this is -2 over 9 pi. My units are inches per minute, and that's what dH dt. I get my units from here, inches, from the height, and I'm talking about minutes, not seconds, so there's where I got my units. This is pi. So that's how you do a related rate problem with a cone. They're all the same. All the related rate problems, the first step is to find an equation that relates all of the variables and the rates that you're talking about. The next thing, sometimes you need to get the equations down to one variable. So usually you can use some kind of conversion. Sometimes it's indicated by this right here. Something like that. Get a conversion where you can substitute one variable for the next. So once you only have one variable on each side, for the smallest amount, the minimum amount of variables you can get, differentiate. So that's this. You must differentiate before you put the variables in. So differentiate and then substitute in all the unknowns or the knowns and solve for the unknown. And so this is your answer for the specific time when h is 3. This would change if h was something else. So keep that in mind.